All right, so today we're going to have more practice with solving systems of equations. We're going to tie everything we did together into one example today so we can see one example done 3 different ways. Now remember, given these 3 different ways, you're welcome to choose which way works best for you. If you prefer one way over the other, you do not have to watch all 3 examples. However, if you want to become really good at this, these 3 examples could help you dependent on how the question is asked. So if you are good and able to do all 3 equations, there's sometimes an easier way to use each one. So we want to follow these steps, all right, dependent on which method we're using. So first we always want to rewrite your equations if necessary. So if we're using substitution, remember one equation has to be in the form y equals because we need to sub it into our second equation. If we're using elimination, both equations should be written in the same form because remember we want them to line up vertically. Everything should line up when you're using elimination, and when graphing they should both be written in that form y equals, because in order to plug it into the calculator we hit that y equals button in the upper left hand corner and we plug it in after we had solved the equation for y. Once we have done that, we want to solve for one of the variables. So either after we substitute, we solve for x, or after we eliminate one of the variables and we solve for the one that's left over, or through graphing. In this case, we are actually just going to find the intersection point right away. After we find that first variable, we plug that variable into one of the original equations to find the second variable. Then we write our answer as an ordered pair, x comma y. So here's our example that we're going to use for all of the different ways of doing this. So with substitution, we'd said that we want to find y equals. So I'm going to rewrite this equation since y is almost by itself here. The second equation, I'd have to do a couple more steps. So in this equation, to get y by itself, I have to undo the multiplication of 6. So I'm going to divide everything by 6. Let's get rid of the 6's here, and I'm left with y equals negative 5/6 x plus 24 divided by 6 is just 4. Now I'm going to take this and plug it in for my y here. So now I have 6x plus 3 times negative 5/6x plus 4 equals 12. So when finding x, now I want to write, I need to distribute first. Remember, we distribute, then combine like terms, then we find the variable. So 3 times negative 5/6 would give me, I'm just going to write it this way so we can kind of see what we're going to do. So times negative 5/6x, 3 times 4 is 12, equals 12. Because I'm writing so large, I'm going to run out of room, but I'm going to start writing that up here. I'm going to combine the 3 multiplied by the negative 5/6. 3 and 6 both have a common factor of 3. So 3 goes into 3 one time, 3 goes into 6 2 times. So now I just have 1 times negative 5/2x. So when I rewrite this, I have 6x plus negative 5/2x. Sorry, that's a 5 plus 12 equals 12. Now I want to combine like terms, which are these x's. All right, so I'm just going to write 6x. Since it's over 2, it's a little easier. I'm going to write 6x as 12/2x plus negative 5/2x plus 12 equals 12. So 12 minus 5 gives me 7/2x after I combine those like terms, plus 12 equals 12. Now I can subtract 12 from both sides. I have 7/2 x equals 0. So that must mean x equals 0. Because no matter what I multiply by 0, I get 0. So in order to get 0, in this case, x has to be 0. Once I have x equals 0, I plug that back into one of the equations above. So I'm going to plug it back into this equation here. So I'm going to put 6 times 0, which we know is 0, plus 3y equals 12. So then just 3y equals 12. Divide both sides by 3. And I just have y equals 4. So then I want to write my ordered pair as 0, 4. So that was by substitution. I know this is a little long, but these problems are long. However, it's important we write it that way. So in the previous example, I used 6x here, so I'm going to continue to use 6x there. Through elimination, I want to stack these up so that they look the same. So actually what I'm going to do here is I'm going to add 5x to both sides of this first equation so that they look alike. So if I do that, I'm going to have 5x plus 6y equals 24 for the first equation, because I just moved that 5x over so it looked just like this bottom equation, right? Because now it's 6x plus 3y equals 12. All right, now we see we have some kind of multiples of y that we can make work to eliminate that. So I'm going to multiply this whole thing by 2 so that now I can get rid of this y, and you'll see how I do that. So I have 12x now plus 6y, see? So now by multiplying the whole bottom by 2, which I can do because whatever I do to one side of the equation, I do to the other. Since I'm multiplying everything by 2, I am doing that, and hence the equation's staying the same because it's remaining balanced. And then 2 times 12 is 24. So I want to subtract these because I have 6y and 6y. So 6y minus 6y gives me just 0. 5x minus 12x gives me negative 7x. 24 minus 24 gives me 0. So I have negative 7x equals 0. X equals 0. Remember, that's what we found last time. That's perfect. Again, if we plug that into our equation here, we did that last time, so I shouldn't need to do it, but I will do it anyway. 6 times 0 plus 3y equals 12. That means all we have is 3y equals 12. Y equals 4 because we divided both sides by 3. And voila, we get the same answer. Coordinate plane, or coordinate ordered pair, 0, 4. That's by elimination. Finally, on a calculator, again, we would use 6 here. So in order to do this on a calculator, we have to rewrite each of these equations. So 6y equals negative 5x plus 24. So divide everything by 6 to get y equals. So now I have y equals negative 5/6 x plus 4. And I'm going to put parentheses around this because when I plug it into our calculator, I don't want the 6 just to go with, or the x to go with the 6. I have to let the calculator know that negative 5/6 represents one number. So I want to always put parentheses around my fractions when I can. And then we have our other equation, which is 6x plus 3y equals 12. First I want to subtract 6x from both sides. And then I get 3y equals 12 minus 6x. Divide everything by 3. And then I get y equals 4 minus 2x. So this here is going to be my y1. When I plug it in for y equals, this is going to be my y2. So I'm going to hit y equals in the upper left-hand corner of my calculator. I'm going to plug these equations in. So negative 5, 6x plus 4 goes in the y1 slot. 4 minus 2x goes into the other slot. Then I'm going to hit calculate, which I believe is second trace on your calculator. So if you hit the second button and then trace, it should be calculator written in light blue up there on the top buttons. If it's different on your calculator, you are looking for that calculate button. It's just CALC. So again, you want to find second trace, hit that calculate button. You're going to be given a list of options. You want to type in 5, which is intersection. Your graph's going to pop up and it's going to ask you 3 questions. You just hit enter 3 times. After you hit enter 3 times, it's going to give you this as your answer because that's what we've already found. It's going to give you x equals 0 and y equals 4. All right. Or another way you could do it is by hitting second graph, which is table, I believe, written in blue above the graph button in the upper right hand corner. So if you hit second graph, that's your table. You're going to see where x and y equal in your table, and then look over at, or where the two y's equal in your table. Where y1 and y2 are equal, you look over at x, that should be 0. So again, x equals 0, y equals 4. Hopefully this method helps you. Best of luck, and maybe we'll go over one more example during live class.